Okay, let's go through this. I'm gonna show you guys a really good shortcut. So this takes us back. Well, I gotta turn off my stuff here. So this takes us back to what we talked about the other day. Right, this takes us back to polynomial division, right? So if I wanna, I am recording, I think. Yeah, I am. Good. Thanks for checking. So what goes where if I divide this out?
One on the bottom.
Okay, bottom goes outside. Good. It's frozen. It is
Let it go.
Shut up.
Oh, there's new.
Frozen too.
Okay, numerator goes inside, right?
Yes.
Okay. Whoops.
That's a cute.
That's cute. So I wasn't missing any powers of x, but remember, if I had been missing a power of x on the top, I'd have to preserve a column for that, right? We have to leave a space because we're going to be subtracting vertically for all the powers of x. So what goes where? Oh, what's next? Okay, so we want to know how many times does x divide into 2x to the fourth. So the leading term outside, we divide into the leading term inside, right? And we get 2x to the fourth over x equals 2x cubed, so that's the first term of that quotient, right? That's the first part of our answer. Now what? Okay, I distribute, so I'm going to multiply that through. So I get 2x cubed plus 4x, or sorry, 2x to the fourth, right? 2x cubed times x is 2x to the fourth, plus 2x cubed times 2 is 4x cubed. Everybody agree?
Wait, where'd you do what?
I just distributed the 2x cubed over the denominator.
Oh, so it's 2x to the fourth.
Okay? And then we're going to make sure you write this down. We're going to put it in parentheses and subtract vertically. Right? So what do we get? 2x to the fourth minus 2x to the fourth cancels. That has to happen. That's why we picked 2x cubed, right? So they would cancel. And then 3x cubed minus 4x cubed is what? Negative x cubed. And then we're just subtracting 0 from the other terms. In other words, we're just bringing it straight down. Okay, now what?
Do it again.
Do it again. Okay, so we get negative x cubed divided by x is negative x squared. So that's our next term, right? And then we just distribute again. So negative x squared times x is negative x cubed. Negative x squared times 2 is negative 2x squared. I'll subtract the whole thing, right? And then I get those cancel, so I get negative x cubed minus a negative is plus x cubed, right? So they cancel. Negative x squared minus negative 2x squared. X squared, because that's adding, isn't it? Subtracting the negative. So I get x squared, bring the others down. I go again. So now what's our next term of our answer? X. X squared, or x times x is x squared, right? In other words, x squared divided by x is x, okay? So I distribute again. So x times x is x squared. X times 2 is 2x. I subtract vertically, and x squared minus x squared cancels. What's negative x minus 2x? Negative 3x minus 8. And then last step. Negative 3x divided by x is negative 3. So I distribute the negative 3 times x is negative 3x, negative 3 times 2 is negative 6, and I subtract, and what do I get? Cancel. Negative 8 minus negative 6 is negative 2, and that's it, isn't it? Right, that's my last, that's the remainder. How do I know it's the remainder? Well, I know a couple ways. I know that x won't divide evenly into negative 2, right? And I also knew that because my last term up here was a constant, so I knew I couldn't go any further in my answer, right? Because think what we're going to get. We're going to, for our answer, we're going to get a polynomial plus a remainder, right? Okay, so then what's this look like? So the answer is, this quotient is equal to the polynomial part of the answer. So I get my 2x cubed minus x squared plus x minus 3. What do I do with the remainder? Right, here's this part. Now what? Where's the remainder go? So there's my negative 2. Good, that's going to go on top. And what's it remain over? X plus 2. Okay, so there's my final answer. Right?
So we pretty much take that number out in front and multiply it by, when we get on the ones on top.
One's up top, that's just what we got right here. Right, when we did the long division, that's what shows up on top of the division bracket, right? So x
Oh,
plus
okay.
2 divided into this many times, but we had a remainder, so the remainder goes over the fraction. Now what if the remainder is 0? Then I don't have a fraction to it, right? Okay, we'll talk more about that later, about what the significance of that is. Okay, I'm going to show you a trick here, though. Now, we've done a bunch of long division problems now, today and then whenever the last day we did it was. I want you to notice there's a trick we can use if the denominator is linear. Okay, so if the graph of the denominator equals a line. In other words, the power of x is equal to 1 in the denominator. Okay? See if you can see a pattern here. So that was our answer, right? Okay, I'm going to show you a trick. What if we take the numerator and we're just going to write down all the coefficients of the numerator? So we've got a 2, we've got a 3, we've got a negative 1, we've got another negative 1, and we've got a negative 8. We just write all those down in order. I have to, if I have any missing terms, I'd have to include the 0 coefficient. So I've got 2, 3, negative 1, negative 1, negative 8. I'll make a bracket. And then the number that I'm going to put out in front of the bracket is going to be the 0 of the denominator. Okay? So what's the 0 of the denominator? If I set x plus 2 equal to 0, what's the solution? Negative 2. So that's the value of x that makes the bottom 0, right? Okay, now watch this. This is really cool. This is called synthetic division. Here's what I can do. I can take the first coefficient. I'm just going to drop straight down. So it's going to pop out of the bracket, underneath the bracket. And then here's the rule. Whenever a number appears under the bracket, we're going to multiply by the number out front, by the 0 of the denominator. So 2 times negative 2 is what? Negative 4. Now, with synthetic division, we do the opposite of what we do with regular long division. With long division, whenever we multiplied and we got a number underneath, we subtracted. So in synthetic division, we're gonna add, we don't subtract, we do the opposite. So 3 plus -4 is -1. Number appeared at the bottom, so what do? Multiply by -2, so 1 times -2 is +2, and we add. What do we get? 1. Okay, now what? One times -2, -2, I add. Now what? -3, okay? Multiply that by -2 and I get 6. Okay, do you see those numbers in here? Where are they?
They're up there.
Yeah, they're right there, aren't they? 2, -1, +1, -3, and there's my remainder. How about that? Yeah. So that's called synthetic division, and it is definitely, whenever you're doing a quotient of polynomials and the bottom is a linear polynomial, that is a lot quicker and easier, is it not? I mean, that's pretty simple compared to that.
That works every time if it's.
Works every time, every time.
Wait, come back. How do you know? Oh, never mind. But is it just a coincidence that -2 is the same in this one?
What do you mean? That's the same as that?
No, the green -2 up there.
Coincidence, total coincidence, yeah. Yeah, it could be anything. So let's try this. Let's try a synthetic division problem.
Yes.
Okay? So let's go through one together and then you can try one on your own. So you tell me now, what's gonna go where?
2.
So I get a 2 out front,
Yes, sir.
because that's the 0 of the denominator, right?
Yep.
Okay, now what? What goes inside? 1,
2.
no, 0. How come?
Because there's no.
Yeah, there's no x cubed term, right? So we have to include a 0 for the x cubed.
Trick me.
Okay, now what? No, 2. What? Then what? Okay. And so we can put our remainder box under there, right? Now what? Take the 1 down. Multiply outside. I get 2. I add. Okay, get 2, right? Now what?
And you use multiply by 2.
Multiply by 2,
You get
4, I add.
Add 'em. You get a 6.
So I get a 6 on the bottom.
Oh, this is nice.
6 times 2 is 12, right? Add them up, and I get 10. 2 times 10 is, I add them up and I get 19. Okay, so now we have to interpret that answer. My remainder is 19. What does all this stuff mean right here?
Coefficients.
Those are the coefficients, right? Now, here's how I recommend you do this, right? They're the coefficients of the polynomial part of our answer, right? So we know that that's got to be the constant. That's going to have to be the coefficient of x. That's going to have to be the coefficient of x squared. That's going to have to be the coefficient of x cubed. If there were more, we just keep going, right? So then what's this mean? So we can sort of think about this. There's going to be an invisible x to the 0 there, which we don't write. There's going to be an invisible x to the 1, x squared, x cubed, and then we're just gonna take a sum of all those, right? So it looks like x cubed plus 2x squared plus 6x plus 10 plus 19 over x minus 2. Okay, you see how that works?
Yeah.
Okay.
Okay, now we go to the.
Okay, so then, that's how we do it. Right, check our answer. Okay, there it is. So I'm gonna show you guys, now I've never shown this to an Algebra 2 class, but I'm gonna show you guys this. So what do you do if you get a linear polynomial on the bottom that's has a coefficient that's not equal to 1, right? Synthetic division is a lot easier to do if you just get x plus or minus a number on the bottom, right? So what do you do in this case? So now think let's set up our bracket. I bet you guys can come up with how you handle this. You just kind of think your way through this. So we got our bracket, right? Let's start with the number that goes out front. What's the 0 of the denominator? So negative, let's write it as fraction. Negative, no, 5 halves, right? So we get negative 5 halves outside. So think what that means, though. That means that we're telling the math gods that we're dividing by x plus 5 halves on the bottom, right? Because the 0 of, when we do synthetic division, the math gods are going to depend on this kind of a process where we're dropping things down and we're multiplying by what's outside, okay? If the number outside is a negative 5 halves, then the assumption is we've just subtracted negative 5 halves from x, okay? So the math gods think we're doing this. They think that we've got on the bottom x plus 5 halves. What did I have to do to get from there to there? What did I do to the bottom effectively? I divided by 2. But if I've got a quotient and I don't want to change the answer, what do I have to do to the top then? I divide by 2, right? If I don't want the answer to change, whatever I do to the denominator, whatever I multiply or divide it by, I've got to do the same things at the top, right? In the same way that if we had, for example, if we had the fraction 4x squared minus 6x plus 10 over 2x minus 4, couldn't I just factor a 2 out of the top, right? I could factor a 2 out of the top, leaving me with, let me give myself enough room here. Anyway, I could just factor a 2 out of the top, and what am I left with on the top?
2x squared.
On the bottom, I could factor a 2 out, and what am I left with? And then I could just cancel those 2's, right? But I got it, so these are equal, right? These are equal expressions. But I've got to do the same thing to the top that I did to the bottom, right? So then what am I going to do up here on the top? What am I going to get? You told me I divided the bottom by 2. I divide the top by 2, right? So on the top, I'm going to get x cubed minus 11 halves x squared minus 5x minus, okay, make sense? Really what I did, technically, I factored out, technically I factored out a 2 from the top and a 2 from the bottom, and then I just canceled them, right? Same thing though, effectively that's the same thing as dividing top and bottom by 2, right? We're not gonna have an effective counter.
That's cheating.
Yeah, that is cheating. I know, I gotta find ways to cheat. So what's our simple rule? Now, the whole point of synthetic division is to make it simple, right? We wanna make this a really quick and simple process. So what kind of a rule can we come up with? Whatever we end up with in front of the x on the bottom, I'm just gonna divide every term by that, right? So on the bottom, on the bottom I know I just get my x plus 5 over 2, so negative 5 halves is my 0. On the top, all I've gotta do is as I'm taking these coefficients and adding them to the top row, I'm just dividing them all by 2, aren't I? Right? So we end up with 2 divided by 2 is 1, negative 11 divided by 2 is negative 11 halves, negative 50 divided by 2 is negative 25, and negative 27 divided by 2 is negative 27 halves. And there we go, right? Make sense? Okay, so let's do this. What do we get then? Bring the 1 down, and I get 1 times negative 5 halves. Negative 5 halves, and I add. What's negative 11 halves plus negative 5 halves? Negative 16 halves, which is negative 8. Okay, I'm going to multiply negative 8 times negative 5 halves, and that gives me what?
20.
Negative 20.
No, 20.
Positive 20. Negative 25 plus 20. Negative 5 times negative 5 halves. 25 over 2, good. And if I add those up, negative 1, right? Negative 2 halves. Okay.
The last one is always going to be the extra.
Yeah, right. So then that just tells me, right, that just tells me that I've got, that's my constant coefficient of x squared. So I just get x squared minus 8x minus 5 plus negative 1 over 2x plus 5. Okay? Actually, how come it's not negative 1 on top? What do I have to do? What's really going on the bottom here? It's not 2x plus 5. What is it?
X minus 5.
Ah, okay, right. So on the bottom, everybody see this on the bottom? Yeah, look at this. On the bottom, right, I've really got x minus negative 5 halves. I've got my x plus 5 halves.
We'll always take the number out and bring it back down to that.
Yeah, yeah. But that's not a very good way to write that, is it? We don't want to have a fraction on the bottom. So we're gonna clear the fractions there. We're just gonna multiply through by a 2, right? See what I'm saying? We don't want to have that 5 halves on the bottom, so we'll take this remainder term and we're just gonna multiply both the top and the bottom by 2 to clear the fractions on the bottom. Right? So we end up then with x squared minus 8x minus 5 plus, on the top we're going to get a negative 2, and on the bottom, when I distribute the 2 through, we get our 2x plus 5, right? So once again, if you're just kind of cranking through a bunch of synthetic division problems and you want to kind of automate that and make it something you don't have to think too much about, think what we did, right? When we created our coefficients here, we divided everything by 2, right? So when we're done with the synthetic process, we want to go back to having that denominator. And so all we got to do, when I get a -1 in the bracket, all I've really got to do is just multiply again by 2, right? To undo the dividing by 2 that we did previously, right? So really that should have been, like when we wrote this down, we could have immediately known that on the top we're going to multiply by 2, so we can have our 2x plus 5 again on the bottom. You get the idea? Okay. Yep.
So, just to go back.
Yep.
So the number up front is -5 halves, and then when you bring it down to the bottom, you do the opposite. So
Well, yeah, because it's x minus -5 halves.
Okay,
Right.
so it's always the base, like the actual.
Right, it's always x minus whatever this 0 is, right? Okay. Okay. Let's do maybe one more of those, just for practice, because those are kind of tricky. Easy one?
I wanna have one that's 6.5 minutes.
6.5 minutes, okay, I can probably arrange that.
Okay.
Okay, let's try that guy.
That's Big Betty right
That is.
there. Oh, Keenan, I like Keenan.
Okay, go. Oops. Go. Try that.
Oh.
Ooh, we don't have much time. Let's maybe go through this one together. We don't have much time. So what goes out front? -3 halves. What are the coefficients on top? 1. Good, -7. Okay, so we drop the 1 down, times -3 halves. It's -3 halves, and we add. What do we get?
Yeah, 5.
10 halves, which is 5. Good. No, or 13 halves plus -3 halves is positive 10 halves. Okay, 5 times -3 halves is -15 halves. So that gives us what, -8 halves? -4? -3 halves times -4 is 6. So that gives us -6. And then -6 times -3 halves is 9. So that gives us a remainder of 2. But what do we have to do to our remainder? We got to multiply it by 2, right? Okay, make sense? So then we end up with, for our answer, we get, that's gonna be x to the 0, x to the 1, x squared, x cubed. So we get x cubed plus 5x squared minus 4x minus 6 plus 2 times 2 is 4 divided by 2x plus 3, right? Make sense? Let's check it. Look good? Yes.
So I, steps like when I getting the 0, and you're asking about the top. I just got double the answer on the bottom.
Right.
So you can technically actually do it after.
Yeah, I wouldn't do that though. Yeah. Yeah. Say it again. I think it makes more